This is a 360-degree video, meaning that you can change your view by panning this video on your laptop or smartphone. Have you ever dreamed of traveling around the galaxy? I'm not talking about visiting the places close to home in our solar system, like Mars. I mean traveling to other stars and exploring planets that aren't even in our solar system. We call these planets that don't orbit the sun exoplanets. There are thousands of exoplanets that we know of in our galaxy. Sadly, traveling to these mysterious worlds ourselves would take tens of thousands of years. But luckily, we have impressive technology that can identify exoplanets and even paint us a picture of what it might be like to visit these distant planets. Exoplanets get named after the star that they orbit, and many stars have entire planetary systems around them, just like how our solar system has 8 planets orbiting the sun. One fascinating system orbits the star TRAPPIST-1, a star that is too dim for you to see while looking up at the night sky. The TRAPPIST-1 system has 7 known Earth-sized planets, and 3 orbit in the habitable zone. The habitable zone is the area that is the correct distance from the sun, where it is not too hot and not too cold, somewhere that is just the right distance for liquid water to potentially exist. Exoplanets within the habitable zone are places where scientists search for extraterrestrial life. What would it be like to live on a TRAPPIST-1 planet? To start, the star is a red dwarf, cooler and much smaller than the sun. The sunlight would be a red-orange color. On top of that, all of the planets are likely to have one side that always faces the sun and one side that never faces the sun, making it either eternal day or eternal night depending on which side you live on. They are all mostly made of rock based on their calculated densities. Also, although the TRAPPIST-1 system planets are similar sizes to Earth, they are much closer to each other than Earth is to its neighboring planets, Venus and Mars. The distance between this star and its closest planet is about the same as the distance between Jupiter and its moon Callisto. So looking to the night sky from the surface of most of these planets, your neighboring planet, when directly behind, would appear about half as wide as the moon does in our night sky. And instead of taking months or years to planet hop, you could travel through space and make it to the next closest planet in just weeks. So how do we know all of this about the exoplanets? And how do we even know that they are there in the first place? The TRAPPIST-1 exoplanets were discovered using the transit method. The transit method studies the brightness of a star. When a planet passes in front of the star, the brightness slightly decreases, showing scientists that there is an exoplanet orbiting the star. This requires incredible technology. In the case of the TRAPPIST-1 system, 3 of the planets were discovered using the TRAPPIST telescope in Chile. Scientists used the Spitzer Space Telescope to discover the rest. Spitzer operates in space, orbiting the sun outside Earth's atmosphere. Spitzer focused on the TRAPPIST-1 system for nearly 21 days to detect these Earth-sized planets. Another fascinating world is in the Kepler 16 system. Kepler 16b is an exoplanet about the size of Saturn that orbits not one, but 2 distant stars. From the surface or in the cloud tops if it's made of gas, you would see 2 suns in the sky, one rising just after the other. The 2 stars orbit each other. One is about 2/3 the mass of the sun, and the other is a red dwarf that is only 1/5 the mass of the sun. So combined, they still give less energy to the Kepler 16b exoplanet than our single sun gives to Earth, making Kepler 16b a little too cold to be considered habitable. It was also discovered using the transit method by the Kepler Space Telescope. This telescope has been very successful at finding exoplanets. Another exoplanet discovered by the Kepler Space Telescope is Kepler 22b. I know, super exciting names here, but Kepler 22b is immensely fascinating. This exoplanet has the potential to be rocky, like Earth, with a liquid ocean, like Earth, and is within the right distance from its star to be in the habitable zone, just like Earth. However, its diameter is around twice the size of Earth's. It is also theorized that its ocean-covered surface could be an average of about 60 degrees Fahrenheit, putting it on the list for places with possible life. So after exploring some of these exoplanets, would any of you want to move there if you could? I know some of these exoplanets might sound nice, but truthfully, despite our incredible telescopes and scientists, there is still so much we don't know about these planets. We don't know exactly what they're made of, what they would be like, and we definitely don't know if any of them could support life. So, even though we have found thousands of exoplanets, including some that are considered in the habitable zone, the search is absolutely still on for an Earth 2.0.